Right, we need to find the maximum and minimum values of the particular expression given at the bottom here. And we present a solution to this problem in a step-by-step fashion as follows. Right, so we start and say we have been given the cosine of 45 degrees minus x multiplied by the cosine of 45 degrees plus x. And what this is as follows. So you have that this is the same as the cosine of 45 degrees minus x multiplied by the trigonometric sine of 90 degrees minus into 45 degrees plus x. Okay, so this is the case. There's a cofunction change where the cosine function changes to the sine function at 90 degrees minus the argument, minus the angle. So you have this, that this is cosine of 45 degrees minus x multiplied by. So here, this one is the trigonometric sine of 90 degrees minus 45 degrees minus x by distribution. Right. So now, after having applied the distributive law here, this is 45 degrees minus x multiplied by the sine of, now 90 degrees minus 45 degrees is 45 degrees minus x, like so. And so we have therefore that this is the cosine of 45 degrees minus x multiplied by the sine of 45 degrees minus x. Now, what is the meaning of this? Right, so now we clearly can see, therefore, that this can be written as 1 over 2 into 2 times the sine of 45 degrees minus x multiplied by the cosine of 45 degrees minus x, like so. Now, 2 times the sine of 45 degrees minus x times the cosine of 45 degrees minus x is the same as the sine of 2 into 45 degrees minus x. Okay, using what we call the trigonometric double angle formulae, we apply the distributive law to distribute here, because multiplication distributes over subtraction. 2 times 45 degrees is exactly 90 degrees minus double x. So this is 1/2 of the trigonometric sine of 90 degrees minus 2x. Now, this is 90 degrees minus 2x is an angle that is in quadrant 1. And in the first quadrant, using the cast diagram, where you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, the A stands for all positive functions between 0 and 90 degrees, so that the sign is positive, but it changes to its co-function. And using what we call the COCO rule, we're able to convert the sine to the cosine function, so that here we indeed have the cosine of twice x, like so. Right, so we have this exactly. Now, having had these, there are a couple of things that remain extremely important here. A couple of things that remain extremely important. What are the important things? there's something we therefore call the range. Right, because this is a function. So the range, therefore, of this function is minus 1/2. Right, so the range is minus 1/2 whenever you have 1/2 of cosine 2x and in other words, you have that half cosine 2x lies between minus 1/2 and 1/2. And hence the minimum or the maximum first and then the minimum. Right. Let's just write a little bit here to make sure that we avoid any confusion. Hence, the maximum and the minimum values of the cosine of 45 degrees minus x times the cosine of 45 degrees plus x, or so the maximum is 1/2 and the minimum is minus 1/2, and these are the values respectively. So in other words, what we have here is that hence the maximum and minimum values are as given there, respectively. Okay, as indicated, we need to emphasize the fact that the maximum is 1/2 and the minimum is minus 1/2. Okay, so we have that exactly. So because the minimum is this one, minus 1/2, and the maximum is that one there. Okay, now there is method 2 that you can use, because what we used was method 1. Okay, now there are a couple of things that are important here. So because we actually converted the first, this second part to the sine function. So we can convert this first part to the sine function. So we proceed to do exactly that and demonstrate the power of mathematics. All right, so we are here and we are dealing with the cosine of 45 degrees minus x into the cosine of 45 degrees plus x. And this is the cosine of, okay, so this can be converted to the trigonometric sine by using the co rule, the trigonometric sine of 90 degrees minus into 45 degrees minus x. Okay, so you can put some square parentheses here, like so. Okay, so just putting in some square parentheses, and we have here the cosine of 45 degrees plus x. In which quadrant is 90 degrees minus? It is the first where all the trig functions are positive. So this is indeed, we have a positive function here. And by the distributive law, this means we have minus 45 degrees plus x times the cosine of 45 degrees plus x. Okay. Now let's look at these, but look at these very carefully. What is 90 degrees minus 45 degrees? So 90 degrees minus 45 degrees is exactly 45. degrees. So this becomes the sine of 45 degrees plus x. So this equals the sine of 45 degrees plus x. Right, times multiplied by. So the second part is the cosine of 45 degrees plus x. Right, 45 degrees plus x. Right, the two angles are the same, 45 degrees plus x and 45 degrees plus x, but the trigonometric functions are those that are different. So we're going to put here 1/2, and we have 2 into the trigonometric sine of 45 degrees plus x times the cosine of 45 degrees plus x. Okay, now, this is the case. If you have 2 of this, therefore is 1/2 of the trigonometric sine of 2 into 45 degrees plus x. Right, using the trigonometric double angle formula, this equals this. You now multiply through into the parentheses, and we have 1/2 of the trigonometric sine of 2 into, now 2 times 45 is what? It's exactly 90 degrees plus twice x. We've seen therefore that 2 times 45 is 90 and 2 times x is exactly x, like so. And what is the meaning of all these here? So this 90 degrees plus x using what we call the cast diagram. Right, we're able to see that this, we know this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. So the 90 degrees plus is actually an angle that is in the second quadrant in which the sign is positive, but there's something we call the Coco rule. Right, by the Coco rule, we know that the trigonometric sine changes to the trigonometric cosine function, so that this becomes the cosine of 2x, like this. All right, like so. Exactly like so. At this point, we are able to see that we have with us 1/2 cosine 2x, whose range is 1/2 cosine 2x, 1/2. So, and we're able to see therefore that the maximum, let's see the maximum first. What is the maximum? Right, we're able to see that the maximum is what? Checking the maximum, please. Right, so we have the maximum is 1/2 and the minimum is minus 1/2. The maximum is 1/2 and so you can write the maximum is 1/2 and here the minimum is minus 1/2. Okay. Right. And these are the maximum and the minimum of the function cosine of the expression cosine 2x, cosine of 45 degrees minus x, cosine of 45 degrees plus x. Like so. Okay. Now we're going to present the third method. Method 3. Right. There is method 3, in which you have the cosine of 45 degrees minus x, cosine of 45 degrees plus x. Yeah, and then what do we do here? Right, now there is a method we can use to find the maximum and minimum using the compound angle formulae. So in which case, therefore, we perform the expansion here, which is the cosine of 45 degrees, cosine of x, plus the sine of 45 degrees, the sine of x, multiplied by the cosine of 45 degrees, cosine x, minus the sine of 45 degrees, the sine of x. Okay, so the cosine of 45 degrees minus x can be expanded like this using what we call compound angle formulae, and the cosine of 45 degrees plus x can be written like this. Cosine 45 degrees is 1 over the square root of 2, something we call these particular special triangles, square root of 2, 1, 1, 45 degrees, 45 degrees. Cosine of 45 degrees is 1 over the square root of 2. The sine of 45 degrees is 1 over the square root of 2. In which case, therefore, you have 1 over the square root of 2 for cosine 45. And the sine 45 is also 1 over the square root of 2. So it's going to be 1 over the square root of 2, the times cosine x. The sine of 45 is also 1 over the square root of 2, the sine of x, into 1 over the square root of 2 cosine x. And there's just a minus there. 1 over the square root of 2, the sine of x. Right, now we multiply these two. So this is like a difference of 2 squares. Difference of 2 squares, where we say a squared minus b squared is actually a minus b into a plus b, like so. Meaning you can perform multiplication here, multiplying these two, and you have 1/2 cosine squared x minus 1/2 sine squared x. Okay, so we take out 1/2 here as a common factor, which is cosine squared minus sine squared. So if you have 1/2 of cosine squared x minus sine squared x, this is 1/2 of this is the same as cosine 2x using trigonometric compound angle formulae, and the range of this expression is minus of the associated function. The range is minus 1/2 less or equal to 1/2 cosine 2x less or equal to 1/2. Okay, in which case, therefore, the maximum is 1/2, and the minimum and the minimum is minus 1/2. Okay, so the maximum is positive 1/2 from here, and the minimum is that one. Right, so we have solved this problem, and now we can just write a conclusion. After the 3 methods, we conclude hence. We conclude that hence the maximum and the minimum hence the maximum equals 1/2, and the minimum hence the maximum equals 1/2, and the minimum equals minus 1/2 of the expression cosine 45 minus x cosine 45 plus x. Like so. Right, we have solved this problem in detail, and we have got the result, and we're able to infer and conclude that the maximum is 1/2, and the minimum is minus 1/2 of the expression this one here. We have solved this problem step by step, and we are concluding about the results. So yeah, thanks everybody for watching and for joining us, and goodbye to you.